What's going on, everybody? Welcome back to my YouTube channel. Now look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the value of x for which 3 to the power x times 5 to the power x squared is equal to 15. Well, our first step towards solving this question would be for us to decompose this 15, which means to partition this 15. So this expression becomes 3 to the power of x times 5 to the power of x squared equal to, now 15 can be partitioned into 3 times 5. That's it. So our next step will be for us to divide both sides by 5. So I'm going to be dividing the left by 5. I'll also divide the right by 5. Now in doing that, you notice that I have 3 to the power x. Now this 5 we see here is carrying a power of 1. And from indices, since I have 5 at the top and 5 at the bottom, which shows they are dividing, I can take one of the 5 and subtract the powers. For example, the power on the top is x squared and the power on the bottom is 1. So that's subtracting the power. So this is the second law of indices. Equal to, now notice that 5 can cancel off 5, leaving behind 3. Very good. Now our next step will be for us to divide both sides by 3 to the power x. So I'm going to be dividing the left hand side by 3 to the power x. I'll also do the same thing to the right hand side, dividing by 3 to the power x. Now notice that 3 to the power x can cancel off, leaving behind 5 to the power of x squared minus 1 equal to, now like I said the first time when doing the previous step, this 3 is having a power of 1. And since I have the same base, 3 at the top and 3 at the bottom, I can take the base, which is the common base, 3, and subtract the powers. The power at the top is 1 minus the power at the bottom is x. Now our next step will be for us to take the log of both sides. So I'm going to be taking the log of the left hand side, which is 5 to the power x squared minus 1 equal to, I'll also take the log of the right hand side, which is 3 to the power of 1 minus x. Now I'm going to be applying law of logarithm here, which says that whenever I have, for example, a log of a number, let's say a raised to a power of n, this can be written as n, which is the power multiplied by log a. That means we can use this power to multiply log a. So let's apply that law to this expression we have here. So this power is x squared minus 1. We can go ahead and use it to multiply log 5 according to the law of logarithm equal to, we're going to be doing the same thing here. We use the power, which is 1 minus x, and use that to multiply log 3. Very good. Everything is looking well and good. So our next step will be for us to divide both sides by log 5. So I'm going to be dividing the left hand side by log 5. I'll also do the same thing to the right hand side. I'll divide the right hand side by log 5. Now log 5 can cancel off log 5 from here, leaving behind x squared minus 1 on the left equal to, now on the right I have 1 minus x. Now this expression, I want to write it in the simplified form as log 3 divided by log 5. It is still the same thing. There's something I want to bring out from here. Now notice that this is difference of two squares. That means this can be written as x minus 1 times x plus 1, which is an expression in difference of two squares, equal to, now notice that I have x minus 1 here, but here I'm having 1 minus x. But instead of writing 1 minus x, I'm going to be writing x minus 1 so that it looks like this. But in order for this to be possible, I will have to multiply this expression by negative. Now, from the law of logarithm, this expression can be written as log 3 base 5, which means if I have log A divided by log B, this is the law of logarithm, this can be written as log A base B. So that's the expression we see here. This expression is now written like this. Let's go ahead and move to our next step in the following slide. Now, our next step will be for us to move this expression on the right to the left hand side. And when we do that, this negative becomes positive. So we've already got x minus 1 times x plus 1 on the right. As this expression moves to the left, it becomes plus x minus 1 times log 3 base 5 equal to 0. Now we can factorize now. So notice that x minus 1 is common, which we can factor out. And after factoring that out, we have x plus 1 remaining here, plus the remaining expression here becomes log 3 base 5. That's it, equal to 0. So we have two cases. The first case, we have x minus 1 to be equal to 0, or the second case is x plus 1 plus log 3 base 5 is equal to 0. So we can easily get our answer from this first case by saying that x is equal to 1. This happens when we move negative 1 to the right hand side. Now, facing this expression, we're looking for the value of x. That means I'm going to be moving every other items to the right. So x will be equal to, as 1 crosses, it becomes negative 1. And as log 3 base 5 crosses, it becomes negative log 3 base 5. And you notice that negative is common, which can be factorized. So x will be equal to negative, let's factor that out, 1 plus log 3 base 5. You know, this negative turns to plus because of the parenthesis that was introduced and because of the negative outside. So there is an expression in the law of logarithm which says that whenever I have a log of a base of a number which is the same as the base, that means, for example, log a base a, you notice that the number is the same as the base. This is equal to 1. Now notice this expression. You notice that the base is 5, which means I can make this a base of 5. But how can I get 1? It is by expressing the number and the base to be the same. That means I'm saying that x will be equal to negative, now log, like I said, since I have base 5 here, I want this log to be in base 5. But in order for me to get 1, I need to make the number the same as the base. That's it. So plus log 3 base 5. That's it. Now, I want to recall again from the law of logarithms. I know the laws are becoming many, right? But don't worry about that. Now, watch. Whenever I have, for example, a log of a base, let's say a, of a number of m plus log of the same base, but this time n, as long as they have the same base, I'm going to be taking the common log, and as long as this is plus, I'm going to be multiplying the numbers, which is m times n give mn. So I'm going to be applying this here. So I have a log that is common, log of base 5. So I'm going to be factoring that out. So I have negative here already. So factor out log of base 5. And remember, I'll be multiplying the powers because I have plus here. So this becomes 5 times 3. And this expression becomes negative log 5 times 3, that's 15, base 5. And you know, this negative can also become a power because there is a coefficient here at the back, which is coefficient of 1, an invisible one of that. So it can become a power here. That means this expression can be written as log 15 to the power of negative 1. Remember, I said the coefficient here is negative 1. And now base 5. So which can also be written finally as log, this is an inverse of 15, which is 1 all over 15 base 5. And there you have it. So x is equal to 1, and the other value for x is equal to log 1 over 15 base 5. There we have it. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.